Today we're going to use the quadratic formula to solve equations. Now, if you're really good at factoring, factoring becomes the fastest way to solve any question. The completing the square technique that we learned sometimes is the fastest, but often it's a little bit slower than the quadratic formula. The quadratic formula, which I'll write out here, just like it's on your formula sheet. Quadratic formula, that is a bad looking 2. Oh yes, there's a nicer 2. The quadratic formula works when you have arranged something in this form, ax squared plus bxc equals 0. So the key thing with solving any quadratic equation is making one side equal to 0 first. You need that if you're factoring, and you need that if you're using the quadratic formula. So in part A, if we wanted to solve for x using the formula, we have to realize that a, b, and c are right there. Whatever number is in front of the x squared is your a. In this case, there's no number written, so a would be equal to 1. Whatever number is in front of x is your b. So in this case, b would be 2. And whatever number is all by itself is your c value. In this case, c would be 7. So using the quadratic formula, negative b plus or minus b squared, which would be 4, minus 4 times a, which is 1, times c, which is 7, over 2 times a. From here, we simplify it a little bit further. So simplify inside the square root. You're going to get 4 minus 28, which is negative 24. 2 times 1 is 2. Can you take the square root of a negative? No. So because of that negative 24 there, we can right away say in this one, there is no answer to this whatsoever. Some of our equations will have that. No solution, nothing's possible. And when we used our formula, we got the square root of a negative number. If you tried to solve this with factoring, this one cannot be factored. So factoring wouldn't work. If you tried to solve this with completing the square, at some point you'd be forced to take the square root of both sides, and the one side would have a negative value as well. So you would also get no solution if you tried to do this by completing the square. So let's look at one that has a solution. So if we go to part B, again, x equals negative b. So now it's negative 2 plus or minus the square root of negative 2 squared would still be positive 4 minus 4. A is 1, and c this time is negative 7 all over 2 times a. So we've done the same thing, plugged our values into the formula the same way, but this time when we simplify it, negative 2 becomes positive 2 plus or minus. Here we get 4 plus 28, which is the square root of 32 over 2. We are almost done, but in all of our mathematics that we do, we need to simplify. And we need to simplify in all forms. So here, square root of 32, that can simplify to 4 root 2, all divided by 2. Now technically, at this point, we can still simplify further, because on the top we have 2 plus or minus 4 over root 2. Since both of those terms divide by 2, we can simplify it. One of the ways that we'll practice thinking forward into grade 12 and later on in this unit one of the ways that we're going to figure out how to simplify this is we're going to see that in the top, there's a common factor of 2. Can you see that I could factor a 2 out of the top? And that can then simplify with the 2 on the bottom. What this means...
Hi, sorry to interrupt.
Hello?
Could you send Carla to...
So what I was pointing at is at this step right here, we're dividing by 2. A common mistake that students make is they'll just go, oh, I'll simplify this 2 and this 2. And that actually isn't correct. What we talk about when simplifying, or when you have a fraction, technically there's like brackets around the top, grouping that all together. So you can't simplify things when you're dividing unless a factor is identical on the bottom. So here, this being all grouped together isn't the same as the 2 on the bottom. But if I factor that 2 out, I create 2 factors, a 2 and this other factor. And now these 2's can be simplified to be just 1. And this equation, our final answer, simplified is 1 plus or minus 2 root 2. Now the reason this is tricky is because if you had real numbers, you never do it this way. You could if you wanted to. So for example, let's play around with some real numbers. If I had 4 plus 8 divided by 4, what would you do? If you had real numbers, what would you do? Would you add the 4 and the 8 together? And you would get 12, right? And then you would do 12 divided by 4 and get 3. So when you have real numbers, you can do things like that. And you don't even notice that you dealt with the top first, like it was together. What would have happened if we canceled out? Okay, so first of all, I'm going to write, we know the answer to this is 3. The temptation that you have here when I said you want to cancel out those 2's, look what happens here if I do that. I cancel out the 4's and get 1 plus 8 is equal to 9. Ooh, that's bad, right? Because we know the answer is supposed to be 3. So if we cancel when we're not allowed to, it causes a problem. But I want to show you that if on the top you decided to factor out a 4, right? You're saying, well, with real numbers, why would I do that? You're right. But what you can do with real numbers works with algebra. What happens if I factor a 4 out of here? Can you see that this would be 1 plus 2? And now, if you simplified those 4's, it does work out to give you 3. So if you're ever concerned about, is what I'm doing with algebra or radicals, does it make sense? Try the same process with simple numbers. If it doesn't make sense with the simple numbers, it probably doesn't make sense with the algebra. But if it works with simple numbers as well, it probably works with algebra as well. So there's our answer, 1 plus the square root, 1 plus 2 root 2. Questions for practice, 4, 5, and 6. Couple of notes. Anytime you use the quadratic formula and you get a square root in your final answer like we did here, that means that there was no way you could factor to solve this. Anytime you solve your answer and you have no square roots, it's telling you you could have factored if you would have done that, and it might have been faster. Okay? One thing you might want to try is try to find out which questions the formula is fastest, which questions completing the square is fastest, and which questions factoring is fastest. So whenever you do a question, you should look at it and say, what will be the fastest technique to try this? And try that technique first.